This is an equation. So is this. And this. And this. And this. But of course, this equation is false. Here's another equation. It's got a variable in it, so it's open. It is neither true nor false. We need to establish what's the value of the variable to make it a true equation. Let's go back to our first equation. N is equal to 42. Well, equations have often been compared with balance scales. The left side of the equation is equal to the right side of the equation. If that's true, then they should balance in a balance scale. So we show that N is equal to 42, and in our balance scale, they balance. If we add 2 of something to each side of the equation, it's just like adding 2 to each tray of the balance scale. And while the new values are 2 bigger than the original values, the two values are equal. And in our equation, we can simplify 42 plus 2 to get 44. So we now know that N plus 2 is 44. We could also triple the amounts in each side of our equation, which means we'd have to triple the amounts on the balance scale. And remember, we have to triple the entire amount, so we use parentheses, so that we do 3 times the sum of N plus 2. And both of those things can be simplified. We get 3n plus 6 on the left and 132 on the right. So here's an equation. 3n plus 6 is 132. We started with n equals 42. Well, normally we go in the other direction. We start with 3n plus 6 is 132, and we try to solve. And in this case, we know the solution is n equal 42. You will also notice that one-word instruction, solve. Well, to solve this one, we would add -6 to both sides, just like removing 6 things from a balance scale on each of the 2 sides of the scale. Well, we have a pair of opposites. They make 0. And 132 plus -6 can be simplified to 126. And of course, the identity property tells us that 3n plus 0 is 3n. And then we have one last step. We're going to divide both sides by 3. And since 3 over 3 is 1, we get 1n equals 42, which of course we know means that n is 42. Well, what we've just discussed is that if you do the same thing to each of 2 equal quantities, the resulting quantities will be equal. Or another way of putting it, whatever you do to the right side of an equation, do the same thing to the left side. And in a more formal way, here's 4 properties: the addition, subtraction, multiplication, and division properties of equality. Stated here. For any real numbers, a, b, and c, if a is equal to b, then a plus c is equal to b plus c. That applies to addition. It also applies to subtraction. It also applies to multiplication. But for the division property of equality, c cannot be 0, because if it was, we'd be dividing by 0, and division by 0 is undefined. Well, let's look at some shorter equations to try to get a better handle on the use of the properties of equality. In this one, I know you can do it in your head, but in order to work longer equations, you need to have an understanding of some of the basic steps. We're going to add -8 to both sides. The property of opposites applies, and we can simplify 53 plus -8 to get 45. And then the additive identity applies, because n plus 0 is n, and there's our solution. N equals 45. A shorter way to show the work is to put the plus -8 right there in the original line. Just kind of squeeze it in there. If it's too small, you might want to recopy the problem so that you have room to add -8 to both sides, but I think it's clear what's going on. Then the 8 and the -8 are opposites, so we cross them out because we think we have a handle on the property of opposites as well as the identity property for addition, so we go straight to n equals 45. In this problem, we're subtracting 13, so we have one little extra step. We apply the definition of subtraction. Then we add the opposite of -13 to both sides. Property of opposites kicks in. We simplify 67 plus 13 to get 80. The additive identity tells us that n equals 80. A shorter way to do this is to get your pencil out and apply the definition of subtraction right there on the problem. And then add 13 to both sides as shown. Mark out the opposites. N equals 80. Some people like to recopy the problem because if you start marking over the original problem and you make some incorrect marks and you go back to redo the problem, sometimes you can't read what the original problem was. Here's the n on the right side of the equation, but that's okay. We're still going to apply the definition of subtraction as shown. We're going to add the opposite of -7 to both sides. And you might ask, why did we pick -7 and not 28? The reason is, it's not a left side, right side thing. It's find the side that the variable's on. In this case, it's on the right side. So to get the variable all by itself, sometimes we call it isolating the variable, we add the opposite of the number that's on the same side with the variable, in this case 7. We do the work as shown, and we get 35 is equal to n, and of course we can change that to n equals 35. It's time to formally state the symmetric property of equality. If a is equal to b, b is equal to a, and of course the symmetric property of equality simply states the obvious. Here's 64 is equal to 24 take away n. Well, the question is, can you subtract the variable? And yes. Can you add the opposite of n? Yes, you can. We're applying the definition of subtraction. The number on the same side of the variable is 24, so we add -24, the opposite, to both sides. We mark out the opposites, and we get 40 is equal to the opposite of n. So there's an extra step here. We haven't found out what n is yet. We found out what the opposite of n is. Probably easy way is to just say to yourself, if 40 is the opposite of n, then -40 is n. But you could show it this way. You can multiply both sides by -1. You'll still get that -40 is equal to n, which you can then use the symmetric property, write n equals -40. And an unusual way to do it, but it works, divide both sides by -1. Dividing by -1 and multiplying by -1 have the same effect. So we still get that -40 is equal to n, and n, of course, is equal to -40. Here's a times problem. We need to get rid of that 4 to find out what n is. But we're not going to do an opposite because this is a times problem. We're going to divide by 4 because 4 over 4 is 1, and the multiplicative identity kicks in. If 1n equals 9, then n equals 9. Here's a shorter way to show the work. Just divide by 4 right there in the original problem. Mark out the 2 4s because 4 over 4 is 1. Understand the multiplicative identity. 1 times n is n, and you write n equals 9. Yet another way to show the work is to multiply both sides by the reciprocal of the coefficient of the variable. In this case, the coefficient is 4. The reciprocal is 1/4. We multiply both sides by 1/4. We write these 1s down there for convenience. Anytime you have a number that's not written as a fraction, you can put a 1 in the denominator's place. And sometimes we do it for convenience sake. So now we have all fractions, and we can tell what's in the numerator and what's in the denominator. And then if you remember your multiplication of fractions from elementary school, you could mark up as shown. And now there's a lot of marks on this page, but if you know how to read them, and you know that anything times 1 is itself, you know that the final answer, the solution, is n equals 9. Here's n divided by 7 equals 9. I know you can do it in your head, but let's try to apply some of our properties of equality. One of them is multiply both sides by 7. Now I know on the left side it says 7 over 1, on the right side it just says 7, but 7 over 1 is the same as 7. So we use the one that's the most convenient for each side. We mark out the 7s, and of course 9 times 7 is 63, so n is equal to 63. Here's something else that's worth noting. If it says n divided by 7, that's the same as multiplying by the reciprocal of 7. So n over 7 can be rewritten as 1/7 n. Then we multiply the reciprocal of 1/7. It's pretty much the same problem we just did, and we get n equals 63. And here's one more way to show the work. This is the most unusual, I think, but it's still true. Just as 3 over 3 is equal to 1, well, 1/7 over 1/7 is equal to 1. So we mark them out. And 9 divided by 1/7 is the same as 9 times the reciprocal. So the reciprocal of 1/7 is 7, so we get n equals 63. We can have a negative in a problem like this. We divide both sides by 2, mark out the 2's because 2 over 2 is 1, and n is equal to -28. The coefficient of the variable can be negative. Now we're dividing both sides by a negative number, but we know the rules. -5 over -5 is 1, and n is equal to 13. To summarize, apply the properties of equality as necessary to solve equations.